So what is T1? 1 second. Do you agree with this? That means time to go up is 1 second. You know that time of ascent equals time of descent. Remember that? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
So this particle, so it will come over here. Therefore, after from t equals to 0, move up and it comes down. No? Do you agree with this? Clear? That means when
Yes,
we
sir.
do the part at t equals to 2 seconds, particle returns to point of at any instant, initially is 0. Okay, you know that if the parabola in a parabola ax square plus bx plus c equals to 0, if a is greater than 0, then parabola is open upward or downwards. Hmm? I hear downwards. Huh? I think it's open upwards. I think. Hmm? That means it will be like this. Okay. And A is less than 0, it is open downward. That means it will be like this. Clear? So we will make use of this fact. So here, this is what? Negative. So parabola is open downward or upward? It's negative, no? Downward. Now you can see at t equals to 2 seconds, it is again at the same height now. At 2, t equals to 2 seconds, it comes down. It will move down. At t equals to particle returns to the point of projection. So how does the graph appear? It rises. It is at its maximum displacement here. At what time?
1 second.
T equals 1 second. Again, the parabola will come down. Okay. After that, the particle will move down now. Wait. So the particle further moves down. Understood this? Clear now? Now, at what time it will reach ground, you have to find. When it reaches ground, what is the displacement? Can you tell? Displacement is final coordinate minus initial. See, this we have taken y upward positive. So downward it will be how much? minus 100 minus u. Do you agree with that or not? Hello?
Yes, sir.
So this is a minus 100 uy is nothing but 10t minus half gt square. If you solve that, you'll get 5.5 or something, approximately. That means this corresponds to the time over here. And the displacement is here minus 100 meters. So the graph will be like this. Any doubt is there till here?
Can you please move the page upwards?
Pardon? Understood this? Any doubt is there in this? Just analyze this. See, why I am saying is here in engineering, you have total graphs only. So you should have solid grip on graphs. For momentary happiness, I can skip all this and teach simple ones. Customer satisfaction, but in future it will be a problem. Ensure that have patience and learn this. Any doubt is there?
No, sir.
Any doubt? Any doubt is there, man?
Sir. Completely, sir.
Completed?
1 minute, sir. Complete, sir.
Now try to draw speed versus time graph. Okay, turn this page. Suppose we want speed. How does it appear? This is the tower. The particle is projected up. How does the speed vary? So you can see here while going up and coming down. Here this takes 1 second, we already proved. This coming back, again it comes back 2 seconds. Okay. Now you know that speed at any point, if acceleration is constant at any point in its path of motion, what we learn? Speed while going up equals speed while coming down. Do you agree with this or not? Understood this?
Agreed, sir. Yes, sir.
So that means the particle returns to the projection point. So here you can see this is the origin, no? This is the origin, y is 0 at t equals to 0. This is the speed you have projected with how much? 10 meter per second, I think, no? Speed of projection is 10. So at 2 equals to 2 seconds also, the speed while returning will be 10 meter per second. Okay, now we'll draw the graph of that. How does it appear? Speed means, can it have negative value?
No.
So remember that speed is always positive. There is no question of negative value for this. Okay, now you can see while going up, you have this is 10 meter per second. The speed will be, this is at t equals to 0. The speed gradually decreases. You have v is equal to u minus gt, 10 minus 10t. You can see that this is negative slope, no? What is this, negative slope or not? The negative slope means it should come here, it is straight line. Slope is constant. Slope m equals minus 10, it is constant. And slope is negative. Slope is a constant means graph must be what? Slope is constant means it must be a straight line. So that means graph must be a straight line. Therefore, graph must be straight line. Therefore, the graph will be like this. You can see that slope is constant and you can see what is the slope here, negative one, angle is obtuse. So here t equals how much seconds? Velocity should be 0. When velocity speed will be 0 at 1 second. Agreed? So again it returns back. Okay, that means the speed will increase on its return journey. Understood this? Therefore, the speed will increase like this. Understood this? Clear? And it hits here. Say it hits at some time t equals t. Understood this? How to get the speed of this? At the final point, let the speed be v1. So we have v square minus u square. This downward 2 into upward is positive. The total thing is you have taken 100, no? This is 100 meter, I think. Okay, so you have v1 square equals 100 plus 20 into 100. So v1 will be around to 1100, I think. Approximately 110 you'll get. Okay, at what time? Forward this or not? Clear? So the speed will go on increasing. So it hits the ground at with the speed of how much? v1. Understood this? Clear? And it hits the ground already calculated at what time? 5.5 seconds. Understood this? The graph will be speed decreases while going up, again while returning. Understood this?
Yes, sir.
This is A, B, and this is C. So this is the point of projection B. Again it comes back. It goes on. Is it clear?
Yes,
Now
sir.
try to plot the velocity versus time. Shall I turn this?
1 minute, sir.
Easy on it, no? Finding any difficulty in graph?
No, sir.
Hmm. Shall I turn this? Those who have finished this, just try velocity versus time graph.
Okay, sir.
Completed, sir.
1 minute, 1 minute.
Speed can never be negative because speed is distance by time. Distance is actual path. It cannot be negative. Whereas displacement is change in position coordinate. So position coordinate can be negative or positive. That is the reason why displacement can be negative.
Completed, sir.
Now we can take this. The graph is nothing but velocity versus time. How does this appear? You are throwing up, no? As you know, while going up, it is 10 meter per second. At the same point, it is minus 10 meter per second. Here it will come at 110 meter per second downward. This is at t equals 5.5 seconds. So this is at t equals to 0. Again, back at what time you will have here? T equals 2 seconds. So the particle will go up, velocity will be 0 at t equals to 1 second. All these calculations we have done just now. Agreed or not?
Sir,
Right.
I have a doubt.
Tell me.
Sir, in the previous that speed into time graph,
Hmm.
the velocity we found was 110, right? But it is not coming 110, sir. It is not
How
the
much
root
it,
of
how much are you
2100, sir.
getting?
That is
2100, how much it?
2100, sir. If you take it roots, it will come 45 point something.
Square root of this, huh?
Yes, sir. Square root of 110 is 1 lakh to 21,000, sir.
0. How much it comes to then? 40
45 point.
something. Okay, that's the reason why I wrote.
45.8, sir. 45.8.
Right. This is V1. Okay. That's all.
Yes, sir.
That means here it will be 45.8, something you're telling. Right. So here velocity upward is positive. So this is velocity is this. Initial velocity is upward. So velocity is positive. Now we can use V is equal to U plus AT. At any time the upward is positive, this is downward. Now you can see this is of the form y equals minus mx now, because t is here x-axis, this is the y-axis. So here slope is negative and m is g equals 10 is constant. As slope is constant, what is the graph? Remember, as slope is constant, always the graph must be a straight line. So that means the slope, it will be going on like this velocity. You can see that slope is negative. So here the velocity will be 0 at what time? T equals 1 second. After that, it returns its journey downward. From here inward, it will be downward journey is downward is negative, upward is positive. It goes on like this. Okay, and when it hits this somewhere, the ground point, it will hit it around 5.5 sec. So you got minus 45.8. Understood this? So it's a straight line with negative slope. Shall I turn this?
One minute, sir.
Sir,
Yeah, tell.
here we wrote slope equal to g equal to 10. Okay, sir. So, slope will be positive, no, sir.
Huh?
Sir, here plus then no, sir.
No. Slope is value. M is saying, I'm taking a saying. What is slope actually? Negative only, no? This is negative or not?
Oh, okay, sir. Okay. Yes, sir. Yes, sir. Thank you.
So the last part we want acceleration versus time. Shall I turn this?
Sir,
Yes,
1
sir.
minute. Sir, can't we find from like this, from the displacement and time graph, that concave down?
Which one? What you want to find?
Sir, velocity time graph, sir. Like last graphs, we find it from the displacement time graph.
Yeah, you can find. What is that?
Okay, sir.
No, I'm just telling the available methods, man, how to analyze graphs different ways. Yesterday we discussed some points, today some more. So this week we'll complete the graphs, all points. This is helpful for all chapters, even in engineering also. See, presently you are all still 10th class kids. If I write 2 into 3 and say that is advanced question, you'll believe, because you don't know what is advanced question, no? So after 2-3 months, you'll be expert, you'll be knowing. So I should not miss any point. So every method I'm telling, you have to analyze. Assignments are there now. In that, many graphs will be there. Sit with them, fight with them, wrestle with them. Finally, you'll become an expert. That's what I told. 99%, 95% your own work only. I'll tell many things. This advanced question, it came in exam. I only taught. So the rule is after the examination, I will be teaching.
Yesterday I posted a question in the groups.
You
We
are.
can always use that acceleration is constant. We can use that formula, sir.
Every time we can use.
Sir, but
You only
direction is changing,
posted.
right?
Direction may change, but did I say that in the derivation, as long as acceleration is constant, you can apply. Here also displacement equation in direction we are always is not changing. Are you not using that? Displacement goes up again, reverses direction. Those equations are applicable as long as acceleration is constant.
Okay, sir.
Shall I turn this?
Yes, sir.
Have patience, man. This is acceleration versus time. Now you can see acceleration. How does the acceleration vary, man? Is it constant or variable? See, we have taken upward positive, no? But G is downwards, no? It is negative, no? Therefore, A is negative and constant. So the graph will be, this is minus 10, will remain constant. Follow this?
Sir.
So easiest graph is acceleration graph. Means at any time, we take any time, the value of A is same. Understood this?
Complete, sir.
1 minute, sir. 1 minute. Done, sir.
Now, let us analyze the same problem. There, in this previous case, we have thrown the ball upward. Now, let us see a situation wherein the ball is thrown downward. That means at t equals to 0, it is thrown with 10 meters per second. This is same 100 meters. We have to find the displacement versus time graph. So what we do is we'll take downward as positive. Okay. So if you take like this, displacement we need. S is equal to displacement. This is y equals to 0, no? Displacement delta y uy plus half ay t square. Y final, initial y is this. So y equals, now can you tell this is positive or negative? Coefficient of t square.
Positive.
A is greater than 0. So you know what you have? Parabola is open upward or downward?
Upward.
Is it correct?
Yes, sir.
Yes, sir.
Understood this?
Yes, sir.
So how does the parabola look like? Draw the graph of this. Open upward means what is the meaning?
Shift.
That is the meaning now.
Yes, sir.
Hello?
Sir.
Is it correct or not?
Yes, sir.
Similarly, y is this. If y equals ax square plus bx plus c, a is less than 0, parabola, suppose if you take this as y is positive, I'm taking, is open on negative side of y. So if y, this is positive y, parabola is open in this way. Understood this? It's applicable everywhere. Now, how does the graph appear? Let us draw the graph of this. This is t, this is the displacement. I'll take this as positive y. So here you have positive, so it is open like this now. Open on which side? Positive side of y axis. So the graph appears like this. Understood this? Hello? Any doubt is there? That means here it will reach here at some point, no? Okay, and if you solve this, this is 100. It will hit the ground at some time. Okay. You can find that from the graph. This is T1. Understood this? I have taken this as a positive. This is positive x. Anyway, you can take. Any doubt is that till here?
Sir, if you take downward as positive means graph's axis also will change, sir.
And naturally, because open on the positive side of y, no? That is the meaning of this. Followed?
Yes, sir. Sir, we can take this axis upward also, sir. At
Now you
this
can
time.
try, yeah, you can take upward, but drawing will be difficult. If you want, you try.
Okay, sir. Yeah.
Sir,
Tell. Tell.
at t is equal to 0, the velocity is 10 meter per second.
Yes, it is draw.
So,
Yes, it is thrown like that.
oh,
Okay.
okay. Okay, sir.
Previous problem, it is projected upward with 10 meter per second, man. Now we are projecting downwards with 10 meter per second. Okay.
Okay, sir. Okay. Thank you, sir. Okay.
How the graph appears. So previously displacement versus time, speed versus time, velocity versus time, acceleration versus time we drew. So now also we should draw all those four, out of which we finish displacement versus time graph. Okay. So this is the displacement versus time graph. Now speed versus time graph. Shall I turn the page? See, this is not only for this problem, but generally I'm saying for anywhere you come across such equations, remember this.
Completed, sir.
Speed versus time. Draw the graph. Have the speed will continuously increase or not? This is 10 meter per second at t equals to 0. As it goes down, you have v is equal to, I'm taking upward as positive, u plus at. So you have 10 plus 10t. You can see this is y is mx. So the slope is what? Positive. M is positive. That means slope is positive and constant. When slope is constant, what do you have? Graph is what? A straight line. Remember? So here we are drawing speed versus time. Speed is always positive. This is the time. This is speed. It starts here at 10 meter per second. It goes on rising like this. You can see that slope is positive. Agreed? So here it will hit with some V1. This is 100 meters. V square minus U square 2 into G is 10 into 100. So you will be getting some value here. It will hit the ground at V1. Clear? Followed this or not?
Yes, sir.
Then velocity versus time. Can you draw that? Velocity versus time.
Sir, it is same as speed over time, just in opposite direction.
Which one?
Velocity over time graph. Will it be same like speed versus time?
Almost graph will be same one.
Downward direction.
Yeah. So return this. Speed is always positive. It can never be negative. So return this.
Yes, sir.
Draw velocity. Quick.
Done, sir.
Now we have to draw the same situation. Velocity versus time graph. See here we have taken the tower. The total distance. The particle is projected down with 10 meter per second at t equals to 0. It comes and hits with some velocity, say v1. Okay, follow this. Now if you take downward as positive, we have V, U is plus G, T. Here also the slope is same thing you'll get. Slope is positive, Y equals C plus Mx. So M equals G. Slope is positive and constant. Therefore, graph is a straight line. So you can draw the graph like this. This is, if we take this axis, downward axis as positive, then the speed, it continuously has 10 meter per second at t equals to 0. Okay. This is around velocity, no? Understood this? The speed,
Sir.
negative value continuously increases. Agreed? At some point, so this is a t
V1.
equals t1. You can make the calculations at t1, this will be v1. Understood this?
Yes, sir.
And as usual, acceleration versus time graph you can draw. Finished this?
Yes, sir.
Shall I turn the page?
Sir, is saying that slope is positive, but in this case, slope is negative, no, sir.
Which one?
Here, if we draw line, parallel lines, theta is obtuse, no, sir. Here, theta will be obtuse, no, sir.
Graph slope is negative, but we got from equation slope is positive.
One second. See, you're forgetting one thing. This is positive we have taken now. If we take, if we extend this, angle made with positive x-axis measured in anti-clockwise sense. What is that?
Okay.
Or you want, you told it usual axis, you draw, you'll get the same thing. I want to ascertain one thing, that you can choose the axis in any way. Understood this?
Yes, sir.
Yes, sir.
Shall I turn this?
1 minute, sir.
The only thing is using right hand, this is x, this is y, no? Right hand thumb rule you should use. X crossed with y, x to be turned into y, no? So here also x turned into y. If you take this as y positive, if you take x, you cannot curl in that. Okay. Shall I turn this? You try this with usual access and any controversies there, you have doubts group, no? You can post it. Clear?
Yes, sir.
The more doubts you are getting, the more chances you are learning. Remember. Otherwise, 2 into 3 is 6. Very good. You understood, no doubt. That is useful for IIT. Yeah? In one stroke, if you are understanding, that's not your IIT. As you know, I'll take acceleration versus time graph. Your wish, if I take this as positive y, this, then what will happen? This is the positive. So what will happen? The graph will be a constant at plus 10 meter per second square. Agreed. The acceleration versus time. It is always constant now because I am taking downward as positive. Therefore, A is G downward. Therefore, acceleration is positive and constant. Understood this? Clear?
Sir.
Shall I turn this? Completed?
Completed, sir.
Now, all of you try this graph. Same problem, but velocity is 0. Dropout means velocity is at t equals to 0. Same 100 meters. It will come here with V1 at t equals to t1. We want displacement time graph. Same thing, all those 4 graphs we will draw. Displacement versus time graph. What you have here, as usual, if you want, you take upward as, we will try this. Then what you have downward is negative now. If you draw like this, what is displacement delta y equals uyt plus half ayt square. Okay, this is final. Negative initially 0, 0 plus half into minus at square. Agreed?
Yes, sir.
Any doubt is there here?
No, sir. Yeah.
As t increases, y increases, no? Y is negative, no? Y is negative, remember that. Y is negative, G is negative. Agreed? So, as you know, the graph will be like this or not? Here, this is t
Sir?
equals
The video got
T1.
stuck.
Video got stuck, sir.
Sir, video got stuck, sir.
1 second. Now,
Yes, sir.
understood this?
Yes, sir.
Shall I turn this?
Yes, sir.
One doubt, sir. Sir,
Tell.
from this equation, no, sir, y equal to half gt square. From this we can
Hmm.
analyze parabola is open upward, no, sir.
For positive y, it is open upward. For negative y, we are drawing for negative y. How much it will be?
Minus half. Minus 5.
Now, what is the slope of this? Negative or positive?
Negative, sir.
Negative. Negative means open which side? Downward. Open on the negative side. I am drawing for minus y now.
Yes, sir.
Then we can't cancel the negative sign.
If you want to cancel, you take positive y. You can cancel, but how the graph appears, we can. This is negative y coordinate. For negative y coordinate, how the graph is, the coefficient is how much? When you are drawing negative y versus t, we are drawing minus y versus t. Okay, then what is the coefficient you have here?
Minus 5.
Negative.
Minus.
Negative means open on the negative y-axis, no? The negative
Yes,
y-axis downwards, no?
Yes, sir.
Yes, sir. Yes, sir. Clear, sir.
First fix up what is your, which direction you are taking. You are taking negative y. So negative y versus time, because time cannot be negative, no?
No, sir. Cannot be no.
Understood this?
Understood,
Speed
sir.
versus time. Next graph is speed versus time. Draw. Allow you completed this.
Yes, sir. Completed.
Yes, sir.
Yes, sir.
Speed. And typing equal as positive, you can see V is equal to minus U plus 80, no? So V equals 0. Speed means you should take only modulus, no? It's a straight line passing through the origin, no? So this is theta. Understood this? Clear?
Clear, sir.
This is speed versus time. Shall I turn this?
One minute.
Completed?
Yes, sir. Completed, sir.
10 seconds.
Velocity versus time graph. Draw. How does it appear? Again, the same situation.
Graph will be on negative side.
Hmm. Zero. Upward is positive, no? Now you can see slope is negative and constant. This is the graph. The positive if you take, time is negative. At t equals to 0, velocity is 0, as this is increasing now, straight line only, no? So at some time t1, it hits down with a velocity v1. Now you can see slope is negative only now. Previously asked some doubt now, see. Am I right? So we got slope is negative. Clear? And
Yes, sir.
the last part, acceleration time graph. This is t, the acceleration, we are taking upward positive. Acceleration is downward now. This is a equals g, which is negative. Why? Because we are taken upward as positive. So the acceleration versus time graph will be this. Because it reaches the ground at t1. Understood this?
Yes, sir.
Sir, if we take downward as positive, the gravity will plot upwards. Go ahead,
Yes,
that
yes.
is-
Acceleration will be up on this upward. I think by this time you had a little bit knowledge about how to draw a graph, this concave, upward and up.
Yes, sir.
Yes, sir.
See, this plotting of graphs, everything is there in your mathematics second year. But by the time you learn that, we will finish physics. Next year, November or December, they will be teaching. So that is the reason why, because it is a part we have to know graphs, all this in the beginning only. So that is the reason why the slopes and all I have to explain. So when you learn this in math, it will be very easy because already the difficult stage you have come across in the introduction. Same thing, differentiation, integration you learned here. Now in mathematics, when SAR teaches, you feel easy. Because already we have done this. So second time it will be like revision for you. Till here, any doubts are there?
Yes, sir. To hear this clear.
I will remove this, okay? Right. Take another problem. A car accelerates from rest. Okay. At a constant rate alpha. for some time. After which it decelerates beta. Use graphical method. Normal method you can do. See, the car starts from rest. We need V is equal to U plus AT. Okay. So here U is 0 now. Therefore V is equal to AT. Okay. As T increases, that means this is Y is MX. So straight line with A is positive, no? As car is accelerating, A is positive. Okay, so we can say that the graph will be a straight line passing to the origin. Okay, what is the slope of this? M is nothing but A. So this is theta or alpha. Tan theta equals acceleration. That is given as alpha. So it reaches its maximum value. Then what he says, it decelerates. Deceleration means afterward the car decelerates. So during deceleration, this is at some time, T1. Okay, so from here to here it is T1. Now let us see from here what will happen. Vmax, car decelerates. This is what he told or not?
Yes, sir.
So car is decelerating means velocity decreases, no? So you have V is equal to U minus A T at any instant. Do you agree with this? Follow this or not? Now what is the slope of this?
AT.
Slope is negative. Okay, understood this? Therefore, the car decelerates like this. Understood this? Say from here to here you take T1. Then suppose we take this as a T2. Agreed? Followed? The velocity will become 0, no?
Yes, sir.
V equals to 0. What you have? T equals how much? So it becomes 0 at this point. Understood this? Clear or not? Any doubt is there? So we have successfully got the graph. Understood this? Now from the graph, what you can infer, let us see. The first thing you can infer is, see from graph, I'm writing here. You can get What is slope mean? Acceleration is slope, no? Is nothing but tan theta. What is tan theta? Opposite by adjacent. Agreed. So what is agreed or not? Understood this? So what is T1? Using graphs, how to do I'm teaching. Do you need doubt is that till here?
No, sir, clear.
So suppose this is something, say some theta 1. What is tan theta 1 mean? Opposite by adjacent. Agreed. So this is nothing but great. So what is the slope of this? Slope means this one, you know.
Yes, sir.
That is given as what? Beta only, no? Remember? Deceleration is beta, no?
Yes, sir.
Yes, sir.
Deceleration is beta. Agreed. So here you have tan theta 1 is nothing but beta. Therefore, you can easily get T2 is how much? Vmax by beta. Agreed. Now I'll write here. What is the total time meant? T1 plus T2. What is T1 you got? Vmax by alpha. What is this? Vmax by beta into T. So find out Vmax. You can take LCM now. Alpha beta by alpha plus beta into T. Take LCM. Any doubt is there?
No, sir. Yeah. Sir, what now, sir?
Kelly.
Beta, no, sir. Tan theta 1 equal to beta. Before that, why we took minus beta, sir?
Where this one? This one.
Yes, sir.
This
Yes,
is
sir.
deceleration, no? He gave
Yes, sir.
deceleration. Do you agree with this?
Yes, sir.
Deceleration minus A only have to take, no? Acceleration means plus A. Deceleration means minus A.
Yes, sir. Yes, sir. I agree, sir. I agree. Understood, sir. Yes.
Understood this?
Understood, sir.
Completed?
Go ahead, sir.
Shall I remove this?
1 minute, sir. Minute, sir.
See, this problem can be done like this also. This is velocity is 0. This is Vmax. Let the time be T1. So here, this is alpha. Acceleration is alpha. So you have Vmax. V is equal to U plus alpha T1. So T1 is Vmax. Without graphs also you can do. Great. So here the velocity will become, and finally comes to rest. Velocity is 0 here. But in this case, this is motion. So this is the acceleration which is opposite. That is a retardation now. And let the time be from here to here, some T2. Then you have V is equal to U plus minus B T2. So T2 is how much? V max by beta. From these two you have T1 plus T2 is V max by alpha plus V max by beta. So same thing you get. So you can use graphical methods if you want. Otherwise, because you are writing an objective test now, whichever you feel easy, you can do. Sometimes graphical method will be easy. Understood this?
Yes, sir.
Shall I turn this?
1 minute, sir, please.
Yes, sir.
Finished? Oh, the last question for today's class. It takes 5 minutes. After that, you can move on. This is V. This is T. So the graph will be, he has given one graph like this. So what is it? Describe the motion, he says. This is from the velocity time graph. See, you can easily tell this. A to B, what is happening, you tell?
Velocity decreasing.
First thing, velocity is positive. Okay. And dV by dt is slow. Acceleration is therefore speed. Velocity decreasing. Follow this. So the particle is slowing down. So it comes to rest. At some time TB. Do you agree with this? Clear or not? And after that you can see from T equals to TB to between these two. Particle is at rest now.
Yes, sir.
Okay. After or for T greater than Tc. Okay. Velocity is what? And you can see that it is increasing. Do you agree with this?
Yes, sir.
Why? Because V is equal to U plus 80, no? Here V is negative and A is also negative. You can see that as the values are increasing with time or not. That means particle is accelerating in negative direction. Okay, that means the particle starts here at A, T equals to 0. It goes on like this. This is the velocity, whereas this is the acceleration. So what will happen? Somewhere the velocity will become 0. It has to change the direction of motion. So this is the velocity and this is speed is increasing. Understood this?
Yes, sir.
It is at rest for some time. After that it crosses.
Can you please move the page a little bit downwards, sir? I didn't copy the question. Thank you, sir.
While preparing for the exam, you will feel irritated many times. Hiccups will be there. Have patience. 2 years now, this tempo you should have. That means have patience. Never develop negative attitude. One who loses patience cannot win.
Done, sir.
Right then, we can move to your maths class. Okay? Right then. Take care. Bye.
1 minute, sir.
Bye, sir. Thank you, sir.
Bye bye.
stage.